start moving things to get V all by itself. So which do I need to take care of first? 24 or 36? Haley?
24.
24. Why the 24? It's farthest from my V. So we do the opposite. Opposite of plus 24?
Subtract 24.
Subtract 24. So we get 36V still on this side equals, wait, what is 24 minus 24?
0.
Oh, don't freak out if you guys get 0. 0 is like the nicest number in math ever. Love working with zeros. Because what's the opposite of times by 36?
Subtract by 36. Oh, times.
Opposite of times?
Divide.
Divide. And what is 0 divided by anything?
Oh my goodness.
It is,
36.
wait a second. If I have 0
Yeah.
donuts, it is 0. I always go to donuts. Don't know why. So V equals 0.
So it's just V0.
V equals 0.
It's the 0.
Okay. Number 3. Do we have parentheses we need to take care of? Yep. So let's go ahead and distribute. On this side of my equal sign, just look on this side. What do I need to distribute here?
Just the 2.
Good job, Brayden. Just the 2. -4, we're going to worry about later. Just the 2. What am I going to get? 2 times 1.
2.
2. 2 times m.
2.
2m. Let's just bring that little -4 down. This was a positive 2, so put a plus in the middle. Okay, now let's look at the other side of my equal sign. What's being distributed now? What's right in front of my parentheses?
1.
Positive 1?
-1.
-1. Good job. So this -1 needs to be multiplied and distributed. -1 times -2. Negative times a negative.
-3.
Positive.
2.
Positive 2. -1 times 2m.
-2.
-2m. Okay. Parentheses all taken care of. Just distributed. Do I need to move? Yes, Kaylee, question.
When it's like a negative, why don't you put the plus sign then? When it's like, so it's -2m.
Mhm.
Why don't you still put the plus sign in the middle?
Because when we have plus a negative number, when we're adding a negative, it really just means we're subtracting it. Does that make sense?
Yeah.
Great question, though. So mathematicians are lazy. They're not going to say add a negative. They're going to say subtract.
Mr. Boggs' phone.
Cool. Okay, that'll be in the film, too. Okay, are all my m's on one side?
No.
Nope. I have positive 2m over here, negative 2m.
Don't be like,
Just
Yes,
turn it
yeah,
off.
it's driving me nuts.
I don't know how he doesn't have his phone. He's always on his phone, like every single second.
All right, which do you guys want to move? Positive 2m or negative 2m? Which one's smaller?
negative.
Negative 2m. Okay, let's do the opposite, which would be to add 2m. Can add it to my 2m over here.
Should equal 4m.
Great job. That's going to give me 4m. What about this -4 and 2? I can combine those, guys. Those are like terms. What is -4 plus 2?
-8.
Close. I'm in the negatives at 4. I'm
-2.
adding 2. I'd end at -2.
And then we add it to +2, which we cancel it out.
Ooh.
It's gone.
Wait. Whoa. I agree that we need to get rid of this -2. What is the opposite of negative or subtract 2?
Oh, it's a positive. Never mind, it's a 4.
Good job. So then we'd add 2 to both sides. We get 4m equals 4. How do I get rid of that times by 4 now? Opposite of times by 4?
Divide.
Divide by 4. Okay, gets rid of it. We got m all by itself on that side. What is 4 divided by 4?
4. No, it's 1. It's
1.
Yeah.
I'm not really good at dividing.
That's okay. That is okay. Nice. Okay, we won't do all the rest of 4 of these, maybe just 2 or 3.
Let's just
No.
do 6 and 7.
And it's double-sided.
Yeah, we can just do 6 and 7. Oh my goodness, it's only double-sided because of graphs. There are 10 examples total. Okay, let's do number 6. Whoa, lots of parentheses. So let's just focus on those guys first. We gotta take care of the parentheses. Just on this side of my equal sign, what needs to be distributed? What's right in front, Gabe?
The 2x and the 6.
Do I distribute the 2x though? Just the
Just the 6.
just the
I'm not doing
6.
4 and 5.
We're gonna skip 4 and 5. Okay, so just that 6 needs to be distributed. Okay, so what am I gonna get? 6 times negative 5. 6 times negative 5.
Negative.
Negative 30.
Negative 30. What about 6 times negative 4x?
Negative 24.
Negative 24x.
Negative 24x. Okay, then we're just going to bring down that 2x that was in front. So it now says 2x minus 30 minus 24x. Now on my other side of the equal sign, what needs to be distributed on that side? What's right in front of my parentheses on that side?
5.
Positive 5?
Negative 5.
Negative 5. Distribute, distribute. What is negative 5 times x going to give me?
Negative 5x.
Negative 5x. What is negative 5 times negative 5?
Positive
Negative
25.
Positive 25. Whoops, and I didn't leave myself room for this negative 6x. Guess what? That's okay. Doesn't matter what orders he's in, so we're just going to put him on the end. Minus 6x. Whoa. Lots of like terms. Are all of my x's on one side, though?
No.
No, I see negative 24 over here. I see negative 5 and negative 6 over there. Okay, let's go ahead, just to make things easier on ourselves, let's combine these guys on this side. Right? Like terms, let's combine them. What is negative 5x minus 6 more x's? Negative 11x. Okay, then we have plus 25 still. Equals... Ooh, and we have x's to combine on this side. What is 2x minus 24x? 2x minus 24. I'm at positive 2, then I subtract 24.
22. Negative 22x.
Negative 22x on that side. And minus 30. Okay, so my x's still are on both sides, but that's okay. I just combined them to make it a little easier. Now, I like moving the smaller amount. Which one is smaller? Negative 22 or negative 11?
Negative 11.
22.
Negative 22, right? It's more negative. So that one is technically smaller. So we're going to do the opposite of that guy. Add 22x. If you were to choose the 11, though, would you still get the same answer? Yeah. I just like moving the smaller one. Plus 22x. So I get negative 30 equals negative 11 plus 22x.
11.
Positive 11x plus 25. Okay, they're all on one side. Now I can go ahead and start trying to get x by itself. So I need to get rid of 11 and 25. Which do I need to get rid of first?
25.
25. It is farthest from my x. We're going to subtract, do the opposite. Okay, so I still have 11x on this side equals, what is negative 30 minus 25 more? We're getting way more negative, Connor.
Negative 55.
Good job. Okay, and my last step, how do I get rid of times by 11?
Times it by itself.
Close. What's the opposite of multiply by 11?
Divide it.
Divide. Divide by 11 on both sides. X is equal to what? What is negative 55 divided by positive 11? Connor?
It's either negative 5 or 5. Positive.
Negative 5, right? Negative divided by a positive gives me a negative. So answer, x equals negative 5. Alright, we're gonna do one more of these equations, skipping 4 and 5. And then you guys are gonna get to graph exponentials. Woo, I love it. I know you're so excited. Okay, let's look at number 7. Do we have parentheses?
Yes.
Yes, okay. Let's look on this side, just this side of my equal sign. What am I distributing? What's it right in front of my parentheses?
-6.
-6, okay. We're gonna multiply that by everything inside. Lots of 6's here. What is -6 times -6m?
Positive 36m.
Love it. Positive 36m. -6 times +6.
-36.
-36. Bring down this -3. Now focus on the other side of my equal sign. What is being distributed on the other side? What's right in front of my parentheses on the other side?
4.
+4.
+4.
So we're going to multiply by everything inside. 4 times -1.
-4.
Send Diane Pearl to the attendance office. She's checking out.
Yep. Yep, you're absolutely right. -4. 4 times 10m.
40m.
Positive 40m. And just bring down our little +9. Okay. We have some like terms that we can combine. Then we need all of our m's to be on one side. So let's go ahead and just focus on this side still. Where are my like terms? Let's make our lives a little easier. Combine like terms. Kaylee?
-36 and -3.
Love it. Don't have the m's attached. So I'm at -36. I'm subtracting 3 more. Where am I at now?
-39.
Good job.
Oh, that was a guess.
That was a good guess. 36m minus 39 equals, okay, look at this side of my equal sign. Where are my like terms there?
The -4 + 9.
Good job. -4 plus 9, so I'm at -4, but then I'm adding 9. Where am I at now?
It's gonna be a +5.
+5, good job. +5, then plus 40m. We need to move our m's so that they're all on one side. Which should we move, the 36 or the 40?
36.
36. 36 is smaller. Could you move the 40 and still get the same answer?
Yes.
Yep. Okay, we're going to do the opposite of positive 36m, and that is,
Send Isabella Romrell to the attendance office. She's checking out.
yep.
Everyone's like leaving. What's happening?
It's not even the weekend.
I wish I could get checked
I
out.
was gonna be like, yeah, you have an ice pack.
No,
Oh.
I tried to earlier, and they were like, I can give you ice, and I was like, I don't know what that's gonna do.
Okay, we're filming. We're filming.
Stop from swelling.
Okay. Got rid of it on that side. -39 equals 5. What is 40 minus 36 now? 40 minus 36? Connor?
4.
4. So positive 4m. Okay. A lot of steps. Now we can start getting m by itself. I need to either get rid of this 5 or this 4. Which one do I need to get rid of first?
4.
Bella. Which one's
5.
5?
Wait, so what do I do about the notes?
I'll just excuse you from those today. You still need to do the assignment on Canvas though.
Okay, thank you.
Yep. Okay, we do need to get rid of our positive 5 first. So we're going to subtract it from both sides. So I have 4m still on this side equals -39 minus 5 more. It's going to give me what, Connor?
-44.
-44. Okay. My last step is to get rid of that times by 4. I'll
Divide by 4.
divide by 4. Booyah, booyah. M equals what?
-11.
Nice, you guys. So you guys have been solving equations. I know, like, a majority of you have solved equations with me for 3 years now. Almost 3 years. Okay, so you know how to do it. Multi-step just means there's a lot of steps, right? Okay, turn your paper over. This is the fun stuff. Quote unquote fun. I hope you find it fun.
Oh.
Fun.
Ooh.
Whoa.
Okay.
That means.
Okay. Secondary math 1. You guys graphed linear equations. What do they form? A straight line. Secondary math 2, you graphed quadratic equations. What did they form?
A U shape.
A U shape. Okay, we're gonna graph some exponentials, and we're gonna see what shape they create on the graph. Okay,
Did they just do like a straight line across?
we'll see. We'll see what these guys
Maybe.
look like.
Zigzags.
Okay, what do we notice about the actual equation though? Okay, what's now been added? Hint, it's called an exponential. So what do we see?
An X.
In the what spot?
Exponent.
It's in the exponent spot. Okay, so now this is saying 3 to the power of x. Well, here's the best part about graphing anything in math. A table always works. Okay, so when you guys are taking the ACT this year, a table always works. And here's what I mean by that. Everybody draw yourself a little T table. Looks just like that. Okay, on one side, on the left side, you have your x. On the other side, you have your y. What a table does is you are going to choose numbers that we're going to input for x. I like doing -2, -1, 0, 1, and 2. Make that a little longer. We literally just chose numbers to plug in for x, and we're going to see what it gives us for y. Okay? So let's try that. Let's start with the positives first, right? Negative exponents can be a little tricky. So let's start with this guy. So our function or our equation is y to the power of 3, or y equals 3 to the power of. First one is 2. What is 3 squared, you guys? What's that going to give me for my y?
6.
No, 4.
3 times 3?
9.
9. Okay, so when we plugged in 2 to the x spot, we got 9. Right? 3 squared is 9. Okay, let's keep going. 3 to the first power, don't overthink this. 3 to the
It's
power
just
of
3.
1 is what, Eli?
3.
It's just 3.
And then 0 is just gonna be 3.
Wait a second. What is anything to the 0 power?
3. Or that number.
Oh, you guys know this rule. What is
0.
anything to the 0
0.
power is?
0.
1.
It's
1.
1. Okay? 3 to the 0 power is 1. So when we plug in a 0 to our x spot, we always get 1. Guess what? It's always going to be 1. 0, always 1. Okay, now here's the thing. Now we have negatives. Okay, so now we have 3 to the power of -1. This is going back to our exponent rules. And this is from last year. What happens when we have a negative exponent? It does what?
Flips.
It flips, okay? So instead of 3 or 3 over 1, it becomes 1 over 3. That negative exponent flips it, turns it into a fraction. Kaylee,
So
question.
then the -2 would it just be a 1 over 9?
Beautiful. So then,
How's it 1 over 9?
because 3 to the positive 2
Uh-huh.
is 9.
Okay.
3 to the negative 2 flips it, so instead of 9 over 1, it becomes 1 over 9.
Oh.
Okay, so we got our last two, and that's okay that they're fractions. Don't freak out that they're fractions. We got -2 is 1/9, -1 is 1/3. Okay, so here's the thing about tables. These are your coordinate points, right? X comma Y, X comma Y. All we gotta do is put these on the graph. So let's go ahead and do that. Okay, so my first coordinate point is -2, 1/9. Okay, so we're gonna find -2 on our X right here. And then it's only going up to 1/9. That's like barely up. Like barely, right there. Okay.
There you go.
Then we have -1 up 1/3, so -1's right there. Then it goes up just a little bit more to 1/3, teeny bit. Okay, then we have 0, so right here, up to 1, finally hit 1.
And then
1, up to 3, yep. And then our last one, 2, all the way up to
9.
9. Ooh. Okay, so this is what these graphs look like, these exponentials. So exponents, we know, whenever we take something to the power of something, it gets really big really fast, right? Those numbers get really big. That's why you see them get really small. They're never going to absolutely hit this right here, but then they're just going to shoot off and get really big really fast. Okay, so exponents are always going to have this shape right here.
It's like,
J. Or a hockey
Kind-
stick.
Yeah, kind of like a
no,
J.
it's kind of like, what are those graphs in the stock market where they go up? They go. you know
Yeah,
that.
for
Oh,
sure.
crap, we lost money.
Yes, don't want to do that. Okay, we're doing the same thing here, except instead of 3 to the x, it is
2.
2 to the x. Okay, what always works when graphing?
Chart.
Table. Beautiful.
Same
Same
thing.
thing, different name.
Yep. Okay, so same thing. We're going to draw our little table. I like choosing the same input values, so -2, -1, 0, 1, and 2. Gives me some negatives, gives me some positives. Okay, let's figure out what these are when we plug them in. Again, let's start with the positives. That's easier. What am I going to get with 2 squared if I plug in a 2 for the x spot? What is 2 squared?
4.
Okay, so when I plugged in a 2, I got 4. What happens when I plug in a 1? 2 to the first power?
2.
2, just 2. So when we plugged in a 1 for our exponent, we got 2. What is anything to the 0 power?
1.
1. Okay, so then we have our negatives. So just flip those guys. So now 2 to the -1, instead of 2 over 1, it's
1 over 2.
1 over 2. Love it. You guys are great. Okay, then our -2, instead of +2, so 4 over 1, it
1 over
becomes,
4.
good job. And look at that. You guys have all of your coordinate points. Okay, so let's go ahead and graph these guys. Whoops, parentheses around our coordinate points. All right, so my first coordinate point is -2. Okay, find -2 and then go up 1/4 again, just teeny tiny bit up. -1, 1/2, teeny tiny bit up, a little higher than the last one. Then I have 0, 1 right there. I have 1 to 2 right there. And 2 to 4. So again, we see that kind of J looking shape where it's going to get really tall really fast if we were to keep choosing points. Alrighty. Let's do one more. I think you guys are getting the hang of this. Exponential's not too bad to graph, right? Kind of a weird shape. Okay, let's do our last one. Instead of 2 to the x, it's now 4 to the x. Oh, same thing. What always works?
The table.
Table. Draw your little XY table. -2, -1, 0, 1, and 2. Plug those guys in for x, see what we get for y. I like starting with the positives. That makes it a little easier for me. So now it's 4 squared. Okay, when I plug in a 2 for my x spot, what is 4 squared or 4 times 4?
8. 4, 8. 16.
16. Okay, so we're going to get 2 and 16 right there. Okay, what about 4 to the first power?
4.
4. So 4. anything to the 0 power is 1. Okay, now we have our negatives. So instead of positive 1, so 4 over 1, it becomes
1/4.
1 over 4.
And 1/16.
Love it. Okay, you see how doing the positives kind of helps first and then those negatives, just flip them over? That's what I like to do. Okay, let's go ahead and graph these coordinate points now. Okay, so these are all 5 of our coordinate points that we're going to put on our graph. You could keep going. You could plug in as many numbers for x as you want.
Just like plugging money in the stock market.
Yep. Okay, so first coordinate point, -2, up 1/16. That's like teeny. We can't even get that close. -1 up 1/4. Again, a little higher, still very close to that line. 0, 1, which actually is the same coordinate point no matter what our base was, right? That was always a coordinate point. Then we have 1 up to 4, 2, all the way up to 16. So this one really shows us how this guy gets really tall really fast.
Oh, 1/16. It's not even an inch. That's more than that.
Okay. Show me a fist of 5 on graphing exponentials, you guys. Plug it in your table. Put the coordinate points. Nice. I love it. 3s and 4s. That's awesome. Okay.